Hello, I am Aurélien Personas from CNRS, and I'm going to talk to you about EDA4SUM, a system allowing guided exploration of data summaries. This work was a collaboration with Britt Youngman from the MIT and Sihem Amaria from the CNRS. So it's generally understood that summarizing a dataset means finding k individually uniform sets that are collectively diverse. The question we try to answer in this work is how can we summarize a highly complex dataset? Like in this example, how could we summarize it if there was tens or hundreds of different types of galaxies in this dataset? Our proposal is multi-step summarization. Multi-step summarization consists in extending the results of a one-shot summarization algorithm with a summarization pipeline composed of successive summaries produced by set-based EDA operators. So, a summarization pipeline is a sequence of exploration operators closed under set-based semantics. Each item set is defined by conjunction of predicates. So, we defined 4 operators that are implementations of by example, which means that each operator takes an item set as input and returns one or more item sets related to the input set. So, how does the system choose which summary to show the user at each step? We used 3 different measures. First, the uniformity, which indicates how similar the items are to each other in each item set. Then the diversity, which indicates how different the item sets are to each other. And finally, the novelty, which indicates how new the item sets are for the user. So we evaluate a global utility as a weighted linear combination of those 3 measures. Based on this utility evaluation, we designed 2 guidance algorithms. The first one is EDA4SUM, which is a greedy algorithm which executes every possible action to pick the one resulting in the most useful summary at each step. The second one is an end-to-end policy generated by training deep reinforcement learning agents to maximize the cumulative utility of a summarization pipeline. Both those algorithms are usable in 3 guidance modes. Full guidance, where the system decides every aspect of the summarization pipeline, the partial mode, where the system suggests the next operator but the user can intervene, and manual, where the user does not receive any kind of guidance. The system is currently working on 2 datasets, a subset of the Sloan Digital Sky Survey with 2.6 million galaxies, and a set of 232,000 tracks from Spotify. The scenarios in the demo will let the users experiment the features of the application while looking for highly uniform ground truth item sets. For SDSS, it will be galaxy classes from the Galaxy Zoo classification, and for Spotify, it will be the music genres. So let's take a look at the application. So this is the interface of EDA4SUM. In the current pipeline area, you see the current pipeline that has been executed so far with all the operators and the evaluation of the resulting summaries. In the current operator results, we can see the current summary with each item sets returned by the previous operator, the evaluation of the summary, and for each item set, the predicate, the uniformity, and the size of the item set. Here we see that the 2 upper sets are ground truth item sets, since one is mostly opera songs and the other one is mostly classical songs. In the summarization mode area, we can pick the guidance mode, the summarization algorithm, and the weighting scheme for the utility calculation, depending whether the user wants to prioritize the novelty or mostly the uniformity and diversity. Then we have the operator selection area, where the user can decide the operator to execute and its attributes. So at each step, the model selected, or the algorithm in the case of EDA4SUM, will pick the operator resulting in the most interesting summary for the next step. Here we see that the balanced novelty chooses a bifacet and valence on this set. If we pick another model, like increasing novelty, we see that the inference gives this set as input with bineighbors and energy attributes. So let's go back to balanced novelty and execute this one. Here we have the new summary resulting from this operator, and we can keep going on like this for as long as we want. So this was a very short demonstration of EDA4SUM. The application is available online and the code is freely available on GitHub. Thank you for listening.